Hello, today's lesson is double angle identities. Just like yesterday, we learned sums and differences, so here they all are. You should know those pretty well. You work through the worksheet, you begin to memorize the pattern, okay? But we have them there, very small, okay? Anyway, so if you use the sign of 2 theta and you rewrite it as the sine of theta plus theta, I have a sum of angles, and the identity for that is the sine of theta, the first one, and times, the cosine of the second angle, same sign, plus the cosine of the first one, the sine of the second one. Well, if you look at it, those are both the same thing. So you end up with 2 sine theta cosine theta. Okay. And what this is boiling down to is the sine of 90 degrees. It could be written as the sine of 2 times 45 degrees. All right, and you need to use this formula to get it, not just the sine of 2 times the sine of 45, all right? Or it's not 2 times the sine of 45, okay? It's not that. You have to follow the formula, all right? All right, cosine. If I rewrite the cosine, let's be green, is the cosine of theta plus theta. Follow the identity for sums. You get the cosine of the first angle, cosine of the second angle, minus the sine of the first angle, sine of the second angle. Since thetas are the same, you get the cosine squared theta minus sine squared theta. All right, you'll notice down here there's a couple other options. Well, what they did is use their Pythagorean identities. If you replace sine squared with 1 minus the cosine squared, you get cosine. You get 2 cosine squared. Having trouble writing, folks. 2 cosine squared theta minus 1. And likewise, I can replace the cosine squared with 1 minus the sine squared, minus sine squared, and you get 1 minus 2 sine squared theta. That's where these other identities came from. They did a Pythagorean substitution. Okay? All right, the tangent. Let's stay purple. The rule says I have the tangent. Well, this is the same as theta plus theta. All right? So you have the tangent of the first angle plus the tangent of the second angle divided by 1 minus the tangent of the first angle times the tangent of the second angle. Well, tan plus tan is 2 tan. And 1 minus tangent times tangent is 1 minus tan squared. Tan squared. And there's your formula. Okay, so the sum and difference identities is how we got our double angle identities. All right, we're going to do 3 different types of problems with these. One of them is proving an identity. Okay, so I'm going to make some substitutions. I'm going to call this problem A too, because I have 2 more. First, I'm going to replace the sine of 2 theta with what it's equal to. So you get 2 sine theta cosine theta over 2 cosine theta. Then I can come over here and cross these out, and you're left with sine theta, and you're done. Booyah, that was nice. Okay. Part B, they want you to prove that the cosecant of 2 theta is equal to the cosecant of theta. Nope, not cosine, cosecant. Sorry. Cosecant of theta over 2 cosine. The trick on, well, we didn't get there yet. So I'm going to replace this with 1 over the sine of 2 theta. Then I'm going to do a double angle substitution, so that's 2 sine of theta cosine of theta. Then I'm going to split it into 1 over the sine of theta times 1 over 2 cosine theta. 1 over sine theta is the cosecant. and you divide by 2 cosine of theta. And you're done. Okay, I have one more because sometimes they're more complicated than that, and you got to decide which identity to use. So I'm going to scroll down here, and this is number 1, part C. I have the cosine of 3x, and I'm going to rewrite that as the cosine. Oh, and they want me to prove that it equals the cosine cubed x minus 3 sine squared x cosine x. It's nice sometimes to have the answer. It helps you determine substitutions. I don't like that thing, okay? All right, so the first thing I'm going to do is rewrite this as 2x plus x. And that's a sum and difference identity. So this is the cosine of 2x, cosine of x, minus sine of 2x, sine of x. Now I have to make substitutions. I'm ending up with a cosine cubed in my answer. So for this substitution, you know, I have 3 choices up here. I'm going to pick this one because it has a sine squared in it, a cosine squared in it. Okay, so I'm going to replace that with 2 cosine squared x minus 1 times the cosine of x. Over here for my substitution, okay, I'm doing a double angle substitution. I have no choice but 2 sine theta cosine x, and that's times the sine of x. And now I'm going to distribute, so I get 2 cosine cubed minus the cosine of x Is that right? Oh, you know what? Hang on, I'm going to keep going. Minus 2 sine squared x cosine x. And then I go, wait, I've got too many terms, and that's not what I need. So I went, oh, that was a bad choice. So I'm going to back up. And that happens sometimes, guys. So I'm going to go back up to here and replace my cosine of 2x with cosine squared minus sine squared times cosine of x. Okay, so this is my substitution for the 2x. And then I'm going to do this one. I don't have a choice. 2 sine x cosine x times sine x. So this is my substitution for that. All right? Now I'm going to distribute, and I get the cosine cubed of x minus sine squared x cosine x. Over here, I get minus 2 sine squared x cosine x. These two terms, the sine squared cosine, are the same, and you end up with the cosine cubed of x minus 3 sine squared x cosine x. Okay? Which is what we were supposed to get. Booyah. We did it. All right? So sometimes you make a mistake. You got to erase it, start over. All right. Back to our notes. All right, they gave me an angle. First, there's a typo. This should be plus. All right, we're talking about the fourth quadrant. We're over here. Here's theta. It says the cosine is 3 over 5. So it has to be positive in that quadrant. So this is negative 4. 3, 4, 5. They want me to find the sine of 2 theta. Well, that's 2 times the sine of theta, cosine theta. I read those off the chart. The sine is negative 4 over 5. The cosine is 3 over 5. And you get negative 12, so that's negative 24 over 25. All right, the cosine, I can use any of those. I believe I use 2 cosine squared. Okay, let's do this. I did 2 cosine squared theta minus 1. So 2 times 3 over 5 squared minus 1 is 9 times, so it's 18 over 25 minus 25 over 25 is negative 7 over 25. And then to do the tangent, I get 2 times the tangent, which is negative 4 over 3, divided by 1 minus the tangent squared. And now this is algebra. So that's negative 8 over 3, 1 minus 16 over 9. So I'll get a common denominator. This is times 3, negative 24 over 9. This is negative 7 over 9. And then I'm going to multiply by my reciprocal. And you get 24 over 7. Okay? Your other option is to take your sine divided by cosine, and you'll get the same thing. The question is what quadrant is 2 theta in? In quad, well, you've got a negative sine, you have a negative cosine, and a positive tangent. So it's got to be third quadrant. Okay? Good question. Something to think about. All right, let's not cross that out. Okay. All right, this time they gave you the answer, and you got to figure out what the cosine, what the angle is. Well, I'm going to use 2 cosine squared theta minus 1 is equal to 3/4. And I'm going to add 1, and you get 7 over 4. And then I'm going to divide by 2. I get the cosine squared is equal to 7/8. So the cosine of theta is equal to the square root of 7 over 8. And it tells me it's acute, so it has to be positive. Okay, that's it. Practice, 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 y'all.